CCD2 template. Switch to debug mode. Click camera setting and select CCD2. Click fly shot in place 1. Open vacuum 1. Suck one component to first nozzle. Component orientation should be consistent with it in carrier tape. Nozzle need to suck the component center. After it, don't click single capture to take a picture. Compare it by the box edge to check if component position is aligned. If it's not aligned, manually move it to align it. Now it's okay. Adjust camera exposure and gain to get clear edge. The current state is okay. Click fly shot capture to take a picture. After taking picture, you can start to make template. First tool image acquisition, no need to change. Start with the second tool. Tool contour match is for positioning. Click setting to open it. Top parameters, no need for change. This is the search angle. This component can't tell orientation from bottom. Orientation need be detected from side. Therefore, the search angle should be small. If orientation can be detected from the bottom, we can set angle from -180 to 360. For this component, orientation can only be detected from side. We set the angle from -30 to 60. This is matching degree for similarity. We set it from 0.3 to 0.8. The first step is to draw a box for search area. Make it bigger box. Right-click to confirm. Second, we draw box for template area. The box need to cover the component. Don't cover the top image. Box should be a little larger than the component. The middle area has a lot noise points. We need to shield the middle area to avoid misjudge. This is the shielding tool. Select it and click execution of template area. Draw a box to cover middle area for shielding. Right-click to confirm. Before next step, crop must be changed to N or A. Click execution of cropping area. Draw a box to cover all images. This step is to select picture for next tool use. Pull the bar for edge contrast until the frame line is clear with green. The shape border is complete. Right-click to confirm. The cross center should be in the component center. If it is not in the center, we need to adjust it to the center. 1 for offset spacing is the smallest value. Horizontal is for left and right. Longitudinal is for up and down. Move can be in the negative direction with negative value, positive direction with positive value. Enable reversing is to enable rotation. If component orientation can be detected from bottom, we don't need to select Enable Reversing. Now this component has no feature for orientation from bottom. We select this function. Click Execution of Search Area to draw a box for search area. Box covers top image. Click Execution of Template Area to select the feature. This component has notches in different position with different sides. Positive orientation has a notch here. The reverse orientation has a notch here. So we need to draw a box to shield the middle area. After the shielding, we only need the outline. Change from crop to an A. Adjust edge contrast. Complete until border green line is complete and clear. Click Execution of Create Template. After component position is located, we need to find the notch. Firstly, draw a box to adjust the threshold. Pull the bar of threshold interval until black area all with color. White has no color. Then we move the box to the notch center. Pull the bar of threshold interval. Box will be full of color here. 749 is the area value. We set area internal to tell if notch is detected. We set it from 550 to 1000. If area value detected is within this range, it means notch is detected and orientation is correct. If it's less than 550, the orientation is opposite. For opposite orientation, this place is in white and blackness area value is lower than 550. The upper limit can be set to 1500 or bigger. Reversing angle is for rotation. If opposite orientation detected, need to rotate 180 degrees. So set 180 degrees here. Click Execution of Perform Conversion. Click Execution of Test Identify. The first tool for positioning has been done. Close and save task. The second tool is to check the component width. By width, length, thickness inspection, we can find some defectives. Click Setting. Click Execution of Template Image to load picture. Picture loaded here is from last tool's cropping. Click Execution of Linear Parameter 1. Pull the bar to adjust line. Edge threshold can be adjusted. Okay, the first line is drawn. Click Linear Parameter 2 for the second line. This side will not deform. This opening may be deformed, therefore we draw a line here. Close the window. Click on Test Identify. A value will appear. Actual distance is component correct width, input based on component drawing. Click Perform Conversion. Here select True. Click Test Identify. Set lower limit and upper limit. If the size detected is larger or smaller, camera will tell NG. Nozzle will drop component to bin if NG found. Same method to inspect the length. Click Template Image to load the picture. First line. We can draw wherever we want to measure. Set the lower and upper limit. It's done. Close and save task. Before we start to inspect thickness, we need to get side position. We add a contour match tool for positioning. Click Execution of Search Area to draw box for searching. Click Execution of Template Area. Draw a box to cover side image. Use crop to shield the center. Return to N or A, adjust edge contrast. Create template. No need to select Enable Reversing here. Click Execution of Test Identify. Save task. Save task after each tool completed. Last tool image measurement for thickness inspection. Click Template Image to load image. Same method to draw to lines. Click Perform Conversion. Click Test Identify. Set upper and lower limit. Save task. After all tools have been completed, click Fly Shot in place 1. Click Single Capture to take picture for testing. There are coordinates and cross center. It means the template is ready.